Hey everybody, welcome back. Today what we're going to be doing is looking over Cloud DataProc, and we're going to be doing a demo on this one. Now, DataProc is an interesting service in that it's like any other of these cloud services. It's highly scalable, it's highly customizable, fully managed, all of those kind of typical cloud-based attributes that we have. This one is mainly going to focus on running Apache Spark. Now, this is one of those open source frameworks for basically running clusters for managing big data. You don't have to use Spark. You could use other ones such as Flink or Presto or a whole bunch of other types. We're going to be using Spark, and we're also going to be playing around with Jupyter notebooks as well, which if you have never used them before, they're absolutely delightful ways to basically well, you can use them for multiple things. You can do data processing, pure Python. Basically, it's just a browser-based interface for running Python scripts. And you can have Markdown, you can have raw text, you can have Python code, and it's all kind of interleaved in this nice, easy to use notebook. So that's what we're going to be doing here today. And I've got a code lab that we're going to be running through with this. I have already gone ahead and enabled all the APIs that we're going to be needing. So we need DataProc, we need compute, we need storage, BigQuery, and BigQuery storage for all of this. A lot of APIs took a few minutes to get up and running, but we're going to go ahead and do that. And I will highly recommend this one. Create a new project and delete it when you're done, because there's a lot of moving parts here, and it's probably going to be pretty easy to forget to turn something off. So let's go ahead and get up and running here. Now, let me make this a little bit bigger. This is basically what we have going on in terms of our workflow here. So we're going to be using DataProc. It's going to tie in with Spark. Spark is going to basically, kind of lead into, with some extra stuff in between, Jupyter Notebook web interface. And we're going to be using BigQuery, BigQuery storage, Google Cloud Storage, and this is all going to nicely kind of tie together. If you are interested in analytics, if you are interested in Jupyter Notebooks, there is something called collabs, which are not code labs, it is collabs and collaboratory. Basically, it is a kind of a nice Python-based, again, interface. Um, Definitely recommend checking it out if this is something that you're into. I'm not sure if we're going to end up having a lab on collabs or not, but Jupyter at least we'll get a feel for. So I have gotten everything set up here. If you read through the code web, it says it's only going to cost you about $1 to run this. That's this instance over time. I'm going to guess it will take a little bit more resources, but yeah, I'm just going to delete it when we're done here. Now, as usual, boilerplate stuff, the first couple of pages, our project ID is already set. Our APIs are already enabled, so I went ahead and did this part already. And that is where we are at. Nicely in this particular code lab, they give you the Cloud Shell commands, or they show you how to go ahead and enable the API through the GUI. We've been pretty much doing everything in the shell so far. Again, just kind of force you all to get into shell-based editing. All right, next up, we have to create a storage bucket. So we're going to set some environment variables. So we're going to say region equals US Central 1. Again, environment variable, echo $region. Here's my variable, very bash-like command. And let's call buckets. I should remember this for other labs where I am dumping stuff over to a notepad. Just set environment variables. Makes a lot more sense. All right, bucket name equals, what do we call this? Spark bucket. It's called Spark bucket. All right, so we have those. Now we can run our gsutil command. So gsutil, make bucket, and then everything else that we need there. So gsutil, make bucket, -c standard, -l, $region, gs bucket name. And we should see our bucket. Ew, okay, I forgot about this aspect. I don't know why I forgot, but buckets have to be globally unique, meaning everybody else that has created a bucket, you are competing with them for names. So let's call bucket Spark bucket dash Fredericks instead. So I'm just updating the variable name. And run this again. That should be better. Okay, so we have a bucket. If I pop over to the the cloud storage page, I would see this bucket now created. We've done that before, so I'm not going to go ahead and do that. All right, now we have to create our DataProc cluster. So we have region we should have set already. We're going to now set our zone though, because we didn't do that. Let's say US Central 1-A, cluster name. I'm going to make this a touch smaller just so that we can see a little bit more here. On the video, it shouldn't be as bad. You tend to have it big when I'm doing class online and I have to flip back and forth between a bunch of stuff. So region we did zone already, right? So yep, zone, so cluster name equals Spark dash Jupyter. So this is what's going to show up in DataProc. And then bucket name, we already have bucket name, echo bucket name. So we don't have to redo this. All right. We have our variable set, so we've done this step. Now we have to run this long command here, and this is basically going to create the cluster for us. So I'm going to type it out, gcloud beta data proc clusters create cluster name. So this is our environment variable. Region equals $region image version. So we're going to use their versions 1.4. Master machine type equals n1-standard-4. So we're just specifying the VMs that are going to be running in our cluster here. And if you are not familiar with cluster-based processing, typically you're going to have a -4, not =4. There's going to be a master machine that is in charge of all the work and basically distributing the load, and then you're going to have a bunch of worker nodes which will actually do the processing and report back to the master when they're done. Worker machine, okay, bucket equals bucket name, optional components equals, so we're going to use Anaconda and Jupyter, and this is going to get us our Python, and we need a gateway. Hopefully I typed that in correctly. I love to see it. It actually kind of worked. So we're going to skip over here to DataProc just to see what's going on in the console, because we have never looked at DataProc yet, at least video-wise we haven't. So this is spinning up, so we see that it's provisioning, which is basically everything that's going on here, and it's going to create our cluster for us. And again, we don't necessarily have to stick with Spark. If there is another distributed processing-based server that you like, and it's open source and it's supported by Google, you are more than welcome to check that one out. We're going to use this. All right, so the rest of this page, while it's going, just kind of describes the flags. I like this code lab for that because they don't always tell you, what the flags are. You actually have to go into the manual for that. Here, they're being helpful for us, which is nice. Component gateway, probably one worth discussing a little bit. We're going to link together in Apache Knox and inverting the proxy, which gives us nice access to Jupyter. All right, so once that is done, we should be able to go into our cluster and open up a web interface. So I will be back once this is done provisioning.